Hello everyone, my name is Zhang. I work as a software engineering intern at Google. Today I'm going to talk about our framework, OckBPF, which enables user-space C-native mock testing of eBPF programs. This talk will include the current challenges, an overview of OckBPF with an example, the features of OckBPF, and the future work. By far, testing eBPF programs mostly relies on a kernel-based approach. We need to first compile the eBPF program to BPF bytecode, then load it into the kernel via BPF loader. To test this eBPF program, we also need a test program, which calls BPF ProgTest API. Then the BPF ProgTest API will call the provided eBPF program inside kernel via file descriptor. It is both time and resource consuming. For example, at Google, testing a simple eBPF program with a special virtual machine takes several minutes each time, and most of the time is spent on VM spin-up and script initialization. This process slows down the iteration speed, resulting in poor development velocity. Additionally, the kernel brings another problem of flexibility. For example, there are kernel-specific features, and we need to know which kernel version the particular changes went in. And we can perform only E2E tests with the kernel, which could make the preparation very complicated. For example, we had to set up the socket state before testing socket programs, and there's no way to unit test specific routines unless they are exported as programs. Considering that eBPF programs are in sense C programs, we propose to leverage existing C native mock testing infrastructure to dramatically improve eBPF testing experience and enhance productivity. Instead of loading the program into the kernel, we utilize CMock testing framework to generate mock interfaces for both kernel-based helper functions and user functions, and create a test program which sets up mock expectations and invoke eBPF programs. By compiling them into 3 object files, then linking them into an x86 binary output, which can be executed in the user space, kernel helper symbols are resolved to mock library implementation, and eBPF programs can be easily and conveniently unit tested as normal C programs within microseconds independent from the kernel. Here is an example. Say we want to test the eBPF program on the left. It calls 3 helper functions. Accordingly, we create a test program which sets the expectations of the helper functions and calls the eBPF program. It is able to catch an assertion failure when you run a test if there is something wrong with the eBPF program. Then I'm going to briefly introduce the features of OckBPF. First, the mocking process is totally automated since all the dependencies stay in a container. All we need to do is to run a single line of command. OckBPF supports multiple expect types powered by CMock testing framework. We have the control to choose different expect types like expect, ignore, and call back up to different scenarios. You may be curious about whether we can handle tail calls with OckBPF. The answer is yes. The way we handle tail calls is by stubbing a callback because tail calls are achieved by tail call helper function, and will call the callback whenever the tail call helper function is encountered. We also provide a library to support user space map emulation. Since eBPF maps are maintained by the kernel, we do not actually know if the map operations are done successfully or not if not testing in the kernel. Considering that eBPF maps are actually hash maps, we can create a user space hash map and emulate the eBPF map operations in the user space by callbacks whenever the real map operations are called. Actually, there is a limitation to do mock testing. It is difficult to perform E2E tests because we have to handle all the helper functions even if the program to be tested is very complex. To address this problem, we are planning to implement a fake model which can be used interchangeably with the mock kernel helpers to provide flexibility when one desires to test eBPF programs at different abstraction levels. It includes a set of data structures and helper functions of their kernel space counterparts in eBPF testing. The user space map emulation we talked about earlier is actually a part of this fake model. With OckBPF, testing eBPF programs could be much more convenient and efficient than ever before. We believe this framework will improve the development efficiency and benefit the community. Thank you for listening, and I'm happy to answer any questions you may have in the Slack channel.